Have you heard about Phi? Do you know about Phi? I'm about to teach you about Phi. Phi. I first learned about Phi when I read a book called The Da Vinci Code by Dan Brown. The book was so good that they made a movie about it with Tom Hanks and the female in this picture. In the movie and in the book, Tom Hanks is Dan or Dr. Langdon, and the female is called Sophie. I'm going to read a passage from the book. Dan and Sophie are talking to one another because they have just discovered a dead body in the most famous art museum in the world. You may know about it. It's the Louvre in Paris, France. Here's the passage. Sophie shook her head. I was more interested in the mathematics of it, the divine proportion, phi, Fibonacci sequences, and that sort of thing. Langdon was surprised. Your grandfather taught you about the number phi? Of course, she said, the divine proportion. In fact, he used to joke that I was half divine, because of the letters in my name. Langdon spelled out the letters Sophie in his name, phi, in her name, phi. Still descending, Langdon refocused on phi. He was starting to realize that the clues to this dead body were even more consistent than he had first imagined. Da Vinci, Fibonacci numbers, the pentacle. Incredibly, all of these things were connected by a single concept so fundamental to our history that Langdon often spent several class periods on the topic phi. 1.618. At this point, Langdon is going to flash back to teaching his class at Harvard. So, here's his flashback. Langdon wrote his favorite number on the chalkboard and turned to face his sea of eager students. 1.618. Who can tell me what this number is? A long-legged math major in the back raised his hand. That's the number phi. Nice job, Stettner. Everyone meet phi. This number phi, Langdon continued, 1.618, is a very important number in arts. Who can tell me why? Stettner raised his hand again. Because it's so pretty? Everyone laughed. Actually, Langdon said, Stettner's right again. Phi is generally considered the most beautiful number in the universe. The laughter abruptly stopped. As Langdon loaded his slide projector, he explained that the number phi was derived from the Fibonacci sequence, a progression famous not only because the sum of adjacent terms equals the next term, but because the quotients of adjacent terms possess the astonishing property of approaching the number 1.618. Phi. Stop reading. Here's the Fibonacci sequence. You code breakers out there, you could probably break the code on how to, on your own, anyone can create the Fibonacci sequence. It's not too difficult. All you need is a calculator. As you look at this, you can probably tell how to create it. I just read about how to create the Fibonacci sequence. Pretty simple. You always start with the first two numbers, 0 and 1, and all you have to do is add the two numbers together to get the next number. So 0 plus 1 is 1, 1 plus 1 is 2, 89 plus 144 is 233, 610 plus 987 is 1597. You could do this all day, every day. Now, here's the crazy part, the second part of this. If I take the big number and divide it by the smaller number right next to it, I get closer and closer to the number phi, 1.618. So let's go back to the book. Despite phi's seemingly mystical mathematical origins, the truly mind-boggling aspect of phi is its fundamental building block in nature. Plants, animals, and even human beings all possess the dimensional properties that adhere with eerie exactitude to the ratio of 1.618 to 1. Phi's ubiquity in nature clearly exceeds coincidence, and so the ancient scientists assumed The number 5 must have been preordained by the creator of the universe. Early scientists heralded 1.618 as the divine proportion. Hold on, said a young woman in the front row. I'm a bio major, and I've never, ever seen this divine proportion in nature. No, Langdon grinned. Ever study the relationship between females and males in a honeybee community? Sure, she said. The female bees always outnumber the male bees. Correct. And did you know that if you divide the number of female bees by the number of male bees in any beehive in the world, you always get the same number? You do? Yep. Phi. The girl gaped. No way. Way, Langdon fired back. Recognize this? It's a nautilus, she said. A cephalopod mollusk that pumps gas into its chambered shell to adjust its buoyancy. Correct. And can you guess what the ratio is of each spiral's diameter to the next? The girl looked uncertain as she eyed the concentric arcs of the nautilus spiral. Langdon nodded. Phi, the divine proportion, 1.618. The girl looked amazed. Langdon advanced to the next slide, a close-up of a sunflower seed head. Sunflower seeds grow in opposing spirals. Can you guess the ratio of each rotation's diameter to the next? Phi, everyone said. Bingo. Langdon began racing through slides, spiraled pine cone petals, leaf arrangements on plant stalks, insect segmentation, all displaying astonishing obedience to the divine proportion. This is amazing, someone cried out. Yeah, someone else said, but what does it have to do with art? Aha, Langdon said. Glad you asked. He pulled up another slide. A pale yellow parchment displaying Leonardo da Vinci's most famous nude drawing, the Vitruvian Man. Nobody understood better than Da Vinci the divine structure of the human body. Da Vinci actually exhumed corpses to measure the exact proportions of human bone structure. He was the first to show that the human body is literally made of building blocks whose proportional ratios always equal phi. Everyone in class gave him a dubious look. Don't believe me? Next time you're in the shower, take a tape measure. All of you, guys and girls, try it. Measure the distance from the tip of your head to the floor. Then divide that number by the distance from your belly button to the floor. Guess what number you get? Not phi, someone blurted out. Yes, phi, 1.618. Want another example? Measure the distance from your shoulder to your fingertips. Divide that by the number you get from your elbow to your fingertips. Phi again. Want another? Hip to floor divided by knee to floor. Phi again. Finger joints, toes, spinal divisions. Phi, phi, phi. My friends, each of you is a walking tribute to the divine proportion. And that's why anatomy and physiology is so awesome. My favorite class. We will get to learn about the human body this year. We will get to study the systems. We will get to learn the anatomy and physiology and the perfection and really some of the imperfections of the human body. This is Da Vinci's Vitruvian Man. You can see the actual lines that Da Vinci drew for 1.618. So you can see lines all over the place to show that humans, as well as many things in nature, adhere to the number 1.618. All right, so now you know about phi. I'm going to talk to you a little bit about this class in another video. We're going to revisit phi at some point. But beyond that, it's great to, I can't wait to see you all, and we're going to have a great year in anatomy.